Hi. So my name is Scott Jashonik. I would spell it for you, and then the pronunciation wouldn't mean anything, would be caught in a continuous loop. So we're not going to do that. Scott J is good enough. I'm the Director of Product Management at Avere. Just a very quick, my background, I have a pretty various variety background, mostly on the networking side and in software-defined networking. Recently joined last year Avere. I think it's an exciting time in this space, ironically, given all the changes with cloud, and we're going to get into that today. Also, I want to introduce my partner in crime.
My name is Bernhard Bain. You can call me Bernie. I'm Principal Technical Marketing Engineer with Avere. I started out at the company building the support organization, so I've seen the product grow since pre-beta all the way to where we are today with our 4.5 release. I'm here to help address all of your technical questions and start a dialogue about how you guys see our solution fitting into the bigger picture.
Okay. So I apologize in advance that I do have slides. Okay. Not a big fan of slides. Being a product manager and all, that seems a little strange, I know. But, so if anything comes up and you just want to have a dialogue about some aspect of our product or something's not coming across on the slide, just cut me off. We can have a conversation. The slides are meant more as a guide than anything else. And so what the intention here is I'm going to take you, some of you were here last year when our CEO, Ron Bianchini, was here. And, I can't stand in his shoes. All I can do is, try to convey sort of who we are and where we came from and what we're doing. For those of you that weren't here last year, this may be a little bit repetitive for some of you that were here last year. I apologize for that. And then we're going to talk a little bit about sort of the really great opportunity that you're probably all blogging about as we speak, that's happening in all sectors of IT and networking. And that is this major transition into different modes of computing, and how Avere and other vendors are fitting into that space, and importantly, what we're bringing to the table in that space. It's not a sales pitch. Some of the slides, I confess now, and I'm saying it to the camera, I stole from the sales deck, but it was just so I didn't have to recreate something I already had. So if it looks salesy, I'm not trying to sell you. It was just a way to expedite. So who are we? Avere started 6 years ago. The goal was really to come to the table with new ways of optimizing NAS. And the mission of the company now is really to come to the market with this concept of what we call hybrid cloud NAS. And that is a little bit of a nefarious term, I understand that. And so we'll try to define that for you because, quite frankly, the cloud environment is quite ubiquitous and there's all kinds of different permutations. And so it'll be interesting to see what the conversations are here. But we are looking at not only the NAS environments that there's billions of dollars of out there today in data centers, but we're also looking at the advent of the object storage market, and you have different players in that space, as well as cloud infrastructure providers or service providers such as Amazon. And so we really see a lot of opportunity there. We've been doing a lot of work and a lot of learning in that space to become experts in certain aspects of it that we can bring some advantages to the market. Our founders, Ron Bianchini, who is our CEO. The listing of companies, so Ron goes all the way back to Carnegie Mellon. We call ourselves, those of us from Pittsburgh typically call ourselves Pittsburghers. I'm not sure if that's derogatory. We're not edible, at least, right? But I mean, ultimately, he's a dyed-in-the-wool Pittsburgh native, and Bernie and myself and many of the other people sort of share in some of the legacy of the different companies. Mike Kazar, who's our CTO, complete utter genius in developing file systems, and really, he's our CTO. But he's a great CTO because I see what we could do, and then next thing you know, he's over in a cube coding away and checking it into the branch, and suddenly our CTO has helped the product improve. And I love that. So, and what type of customers, one of the things that I love about this company in this space is that the storage concept is ubiquitous across verticals, right? So we have a large footprint in certain verticals, but really, quite frankly, all of the different verticals that you can play in, financials, actuarial, genomics, life sciences of all kinds, and rendering and such, they all have these same similar problems. And these problems, I don't even want to call them problems, I mean, it's just growth. And that is just data, lots and lots of data growing and growing and growing over time. And I think we've only really begun to see the growth curve spiking in data. And you can prove that. You'll know the day that there's more data than we can handle when you start to see the Amazon drones dropping off your packages and checking your blood pressure at the same time and reporting that back to the master data center. And the type of applications that we play in, and I have some history that'll come out. I mean, we front end NAS environments to provide performance and ubiquitous access to multiple backends. That's primarily what we do, but we also provide the ability to facilitate archiving. So there's a lot of movement in the object store with having massive amounts of data that maybe I never have to look at, but the law says I have to keep it, and we help facilitate those types of applications as well. Okay? Any questions before I move off this slide? Moving on. Oops, broke the law. No Q&A. You can just fire away. All right, so very well put together picture of sort of the history of what we do. If you start on the left and you have these traditional NAS environments, you know the players in the space, and wildly successful in the marketplace. And in that environment, you have had some issues over time, which is simply that it's just like anything else. I get more bandwidth, I'm going to do more things. I get more storage, I'm going to try more things. I get more compute, the compute cost comes down. I'm going to grow my application farm, et cetera. And these demands ultimately add up to performance challenges and various problems with scale. And so this, not only that, but it's very expensive to maintain in some cases. And you typically have to have, you end up with a small cadre of experts who understand it. And that's good and it's bad. I mean, at the time, it was what you had to do. And over time, we evolved and have new challenges. More bandwidth, more storage, please, more performance. And so we introduced ourselves many years ago as a NAS optimization solution that you could place in front of your NAS environment. And by using things like read-ahead caching and latency management and write-back caching, et cetera, we could smooth out the performance problems and the spikes that you might experience from trying to push a lot of load against your network attached storage solution. And so, you can tell this is a solution slide because there are benefits, right? So here's your benefits. Unlimited performance scaling. So the nice thing about our product, which is really, I personally think this is unusual. They started out developing the product with this in mind, so it was built into, it's baked into the initial product, that you can add nodes to our solution and you can scale that out, and they do cluster, and so you get availability on top of performance, which is really a relief, to be quite honest with you, because a lot of people go to market very quickly with a solution, and those are hard problems to solve, so they'd rather not try to solve them until they know they're viable. But then it's too late. And also things like global access via the wide area network. So obviously, many years ago, it was fairly self-contained, and then over time, you had a lot of dispersion into different data centers and into different remote offices, et cetera, over WAN links, and the latencies to get to the data were not compatible necessarily with the desires of the requirements of the application. And so you really run into some problems with that. And so we really put ourselves in front of the situation to help not only take care of the performance, but also to take care of the latencies and to help just make the NAS experience scale against these ever-increasing demands that were occurring. Turn to today a little bit, and this isn't even today because everything's moving so fast. This is just today's today, right? All right, today. So what has happened now? 6 years or 7 years ago, Amazon was sitting in a room saying, we've got all this infrastructure. I wonder if we could sell it, So they came up with the concept of, let's build cloud for hire. It's not, you could say mainframes did that as well. But it's a novel idea. It was really great, and it's catching on. And as part of Amazon or Google or Microsoft or Rackspace or Verizon Terramark, et cetera, these guys all come out with the ability to store data, right? So one option is the ability to have a private or a public cloud that you could put data into. And so we see the ability to provide a gateway facility to those types of applications. There's also then another set of players in the market that have come in the past couple of years, which are those that have taken sort of the concepts of the object store and said, look, we're going to go out into the market and we're going to sell alternatives to sort of the traditional NAS that are more in tune with archival capabilities, that leverage the object concept with metadata tagging and RESTful interfaces, that take me necessarily out of sort of the traditional protocols, and it's the new environment. And so there's people that are out there that are selling different economic models of private cloud storage that you could replace in your data center. There's people out there that are selling cloud, which I'm going to get into quite a bit, that have a storage function. And then there's that traditional NAS, and it's like anything else. All this new stuff is coming and it's great. Yeah, and I spent like, $50 million on this infrastructure. I'm probably not going to throw it all out today to hurry up and go do that right away. But it's happening. I mean, there's a lot of action in here. I'm sure you guys hear about it all the time. Okay? So kind of where do we fit some of the things that we offer that are advantages of the Avere solution? We definitely help with the latency problem, especially across WAN links. And with some of the new product that we're coming out with that I'll share with you today, it's even going to be more helpful, because it's one thing just to have a data center to one remote office access, but it's starting to sort of spiral out where you have multiple sites, multiple access, latencies coming into play. Again, I mentioned the scalable performance. So I'm live. Everybody loves the word scale. Every vendor loves to talk about scalability and availability. I'm relieved that Avere built it into the product so that it's not just a term. It does scale. You can add a node, you can add another node, you can add another node, and the system will balance itself out. And they will, the data that's being written that's dirty will be balanced across nodes. And if you have a node fail, there won't be data loss. It's really good that that happens. Yes?
On the topic of scale then, what's your largest deployment from a scale perspective, number of nodes?
Max nodes right now, I would say, are about 30-ish.
Yeah, I think there's 30. I mean, there are customers that have, multiple clusters of, 15 nodes. There are some customers that have larger. But I mean, there are many customers that own 50 nodes and spread them out across their enterprise. But it really depends on what their application behavior is and how they grow out this particular piece of storage for what they're directing at it.
So why would you go with multiple clusters of, let's say, 15 nodes rather than a single cluster of 30, 45?
So it really depends on the workflows of the applications that the customers are doing, right? So essentially, we are the edge filer and we provide this high-speed caching functionality, but it is, it's very, I wouldn't say it's application, you direct an application at it and you size the solution for a particular application. And then as you add more applications, you get noise and you can make the system work, but some customers are actually very intent on fine-tuning the performance experience that they have. Thus, they deploy a cluster of a certain size for a given application. As they grow the I/O or the needs of that application out, then they start adding to that. And then if they have a completely different application, maybe in a different business unit of the organization, they're going to spin up their own cluster and they're going to run their workload against that.
What about adding QoS features instead of?
So quality of service? So that's a very good question. Just very quickly, I want to segue back to that. So we have a use case. It's a financials organization. They have multiple clusters because they have quants that are coding up like very crazy bespoke custom things that really, it's interesting for us because it's like they're testing the boundaries of things, but they don't want to necessarily put all of their quants on the same platform. That causes a lot of, okay, we need a new data set, flush, and then it has an impact on everybody else in the way that they're using the application. But it's a fair point. On quality of service, that's an interesting point too, because when we get into some of the slides about some of the new product, we're also getting new asks from the service provider space. And the asks from the service provider space have a lot to do with multi-tenancy. And when you get into multi-tenancy, there's the authentication and protection aspect, but then there's the SLA aspect. So we don't have everything on the truck that you would want there about providing sort of the platinum customer better caching access than maybe the gold customer. But it's nascent, and it's well known that that's going to be something coming down the line for us. But I don't want to say we have it.
Is there a limitation on how the configuration of the back end is connected to the front end, or are they all connected to all back end NAS boxes? Or?
Well, yeah. So essentially, what it is you build our cluster out, and then you pick and choose the back end NAS devices that you want us to represent, essentially, right?
Okay.
So if you have a NetApp or an Isilon or a ZFS box,
Is there a one-to-one connection between NAS and the front end, or is it?
No. So we have a feature called global namespace, which means that you create this server, a virtual server on our instance, which serves out to the clients. The clients come and mount that and ask for data, and then you take certain exports from each one of your core filers and you configure them into this global namespace with a given path. And then the clients come in and access their data through that path, and then we know where to fetch that data from and cache it then locally in our system. So the configuration is really done through this kind of gluing of the back-end file systems into this global namespace, and then the clients come in and access it.
So I might be a client mounting Slash, and under Slash might be a NetApp filer or 4 exports from that NetApp filer, a cloud bucket. And from my perspective, from the client perspective, I don't know that anything's happening there.
As far as the back end is concerned, multiple ports or 2 ports to each of these would be adequate, or 2 ports in the network that these guys are on. Is that how it's?
Yeah, we have like 10 gig ports coming out the back.
Yeah, we have dual 10 gig ports, and then you can segment. Obviously, depending on what kind of network limitations you have, right? If you have a back-end core filer that lives across the country, let's say, right, and you have a limited pipe there, there's a certain amount of throughput that you can get across that pipe, and then that's shaved off of your 10 gig total throughput there.
I would like to ask a stupid question.
There are no stupid questions.
You are basically a caching and abstraction layer. You are not primary storage.
That's correct.
That's correct.
Okay.
Yeah,
right.
absolutely.
We are a file service provider, if you will, right?
Which is, to be quite honest with you, very good. And you'll see why when we get into the virtual side of the equation.
As you get into the cloud, it becomes a little bit more difficult to discuss that, because now you have to have more functionality up front and stuff like that. Yeah.
And in fact, that's very true that a lot of people, as they're making this sort of transition into public object, it's like anything else. If you've spoken a certain language for 20 years and now you're going to go over here, well, you still want everything that you experienced, but you now want it in this new language. And so you have all of these NAS environments, all these enterprise NAS environments that are looking to the economics of the cloud, the flexibility of the cloud, and they're faced with, but I also want insert long list of enterprise NAS features which have evolved over the last 10 years. I'd like all of that too, please, right? And so that's really the balance and they're having to come up with what that balance is as well, because they know it's a different world. They may not do certain things that they used to do the way they did it, but there's so many cool things that you can do with the cloud that it's worth the trade. And so that's what we're in the middle of right now. Yeah, go for it.
For your object storage or you're interfacing with that, do you support CDMI?
No, we do S3.
S3
dialect.
Is there any plan for the more open standard?
We're definitely as we start to gain more momentum with the object storage vendors, and they start to expose those interfaces and push towards leveraging the benefits of those more standardized interfaces, then definitely. But most of the vendors that we've been working to date already have an S3 compatible API, and that's kind of the fastest path to market to leverage that existing API.
The analogy
and we're waiting really kind of for those more open standards like CDMI to solidify and gain full market traction.
So the analogy on the networking side would be Cisco CLI, right? So Amazon and their cloud and object capability were first to market and really have been very successful. And they came up with an S3 standard, and I won't do the air quote thing. And so anybody that wants to play in that space, that's one of the things that they have to support. But it's like any other facet of technology, there's always going to be this pressure. Let's come up with a proper standard. Let's identify it through a proper body. Let's make sure that it has the feature set that's required. At the same time, there's all these market makers that are going out there, such as Amazon with their S3, and the vendors that are trying to play in that space are following along in the wake of that, right? But yeah, at the end of the day, we're agnostic to what that ends up becoming, to be quite honest.
Yeah, at the end of the day, what we've taught our Flash Cloud product to do is get and put data from an object store. So, the dialect itself, while is being firmed up and spread out across multiple vendors, right now the one that has given us the most kind of versatility is the S3 API.
Yeah. Any other questions in that vein? Okay. So I skipped ahead. Let me just make sure I can continue to skip ahead. Yep, I'm going to skip to this. And this gives you kind of the complete picture of sort of the question you were asking. So, I'm going to have clients of some sort, and that might be an enterprise with all kinds of users running their Windows machines that are using CIFs connecting up to their home directories. It might be...
Hey, SMB?
SMB? Thank you. Well said.
So you guys support SMB3 with all the new capabilities, SMB Direct and
SMB2
and all that stuff?
We're SMB2 today. SMB3 is carved, chiseled into our roadmap.
Okay.
It shall come. It has to. It's inevitable. I mean, yes, it is absolutely going to be there. It's more of a timing problem than it is a should we do it problem. We also then have compute farms. So like I said, we play with, let's use rendering as the example, very large numbers of cores of compute that are going to render the next really cool 3D movie or sitting there bashing against our cluster. I'm not quite sure what
someone
happened
kicked
there.
the...
I haven't moved.
No.
You didn't move.
No, it's part of the show.
Part of the
right?
show.
It's just
That's why
training
we have
your
two.
eyes.
All right. Focus on the left screen.
Just as well you've got active.
Active passive, wasn't it?
Do you remember well that you support SMB at the front end but not at the back end?
Yeah, so the way our architecture is today, we support SMB on the front end for the clients. The majority of what we do, and this is new, the majority of what we do is NFS still, writing to the back. And it was just a path of least resistance to get where we needed to go without having to reconstruct. As of, I would say, 4.0, which is this past summer, we've actually adapted the back end a little bit so that you could do file creates and other operations native.
Native with an SMB with a Windows identity. That way you can do ACL evaluation and setting and retrieving ACLs and all that kind of stuff.
With NFS on the back end, are you supporting PMFS 4.1, any of those yet?
No. So really, we are the PMFS kind of obsolescence layer to a certain extent because we can spread out our calls across all of the available. So if you have like a clustered backend, right? PMFS only makes sense if you have a clustered backend. So let's just say you have a Isilon back there. We can actually spread out all the I/O of all the requests, let's say, that are not within our cache that we need to fetch from that backend. We can spread them out across all of our connections to those Isilon nodes in parallel. And we handle the locking to perform that internally in our layer. And then when clients are coming in and reading and writing data in parallel, we can basically spread all that data out across all the nodes in our cluster.
Yeah,
now,
like for reads and such, if your back-end clusters are already supporting a multi-node read or load sharing type system, it would definitely be beneficial as far as throughput and bandwidth to actually be able to hit every node concurrently to read that data up instead of just locking onto one node.
Yeah, that's a fair point.
no, absolutely.
It's a fair point. We don't support it today. And in fact, I mean, if you think about energy investment, a lot of the energy that we've been investing in is more on the S3 and the object side as of late, as part of our efforts to get into the cloud. But it's a fair point.
What about any sort of NFS4 ACL support?
We have that conversation every 3 to 4 months with a customer about NFS v4. We don't yet have support for the specific features. Our intention is to find the right pieces of NFS v4 to roll out and gradually get there.
Yeah. And just to add to that, no, we do have an implementation where the NFS v4 ACLs can be evaluated for a given user identity that's accessing them on the core filer, and then we take that go, no-go decision that the core filer made, and we store it in our system. And that way we can actually provide ACL evaluation all the way through, but provide the caching layer of the access control at our system, at our layer. So for customers that are like, oh, I need to enforce ACLs, there is a way that can be done with our access caching mechanism.
It was so much easier to read it when it was over here. So, all right, just to kind of fill in a couple of things. We also have some features that we introduced over the past, I'd say 6 to 8 months around moving data. And so they're called Flash Cloud and Flash Mirror. So another advantage, Flash Move and Flash Mirror, excuse me. Flash Cloud was the overall arching thing. And the idea would be to be able to schedule a job or have an automated process that comes into place that moves data off of a particular filer or export that maybe is no longer needed and it belongs in the archive, or mirroring for some basic disaster recovery scenarios, and being able to schedule that and set that up to be automatic as well. So the one thing that we didn't have the slide go over was the concept of the global namespace. I just want to make sure that everybody understood what the global namespace was, which is we have a container that is a vServer, and that vServer can be mapped to multiple exports on the back end, and they can be across core filers. but from the client front-end interface, it's one contained interface. It's a mount point. And so I just want to make, so with the combination of the global namespace and the ability to move data between core filers, whether they're object or not, or mirror data as well, we've been gradually growing that out. And the next slide is sort of a cheap and...
Just a quick question.
Yes, please.
So, excuse me. Per cluster, can you have multiple global namespaces on there?
Yes.
Yeah, absolutely.
So 24, I believe, 24 V servers or global namespaces.
Yeah, when you configure the V server, you'll declare it's going to be global, and then at that point you can just start stacking underneath it what you need.
So can a subdirectory span multiple NAS boxes, or is it subdirectories always associated with at most
With the back end, you're saying?
Yeah.
No, it's So we're taking.
So the global namespace can span
branches.
any number of NAS boxes, but the subdirectories all have to be resident on a
That's
single.
correct.
Yeah.
There's no like embedded
So
cross-linking.
You can't do file-based distribution of what's in a subdirectory across multiple filers.
That's correct.
Right.
That's correct. And that was that's I think the F5 ARX product did something
and Autover
like that.
and
Right.
others.
Right. So no, we kind of chose the path of maintaining the integrity of these back-end file systems and not trying to kind of cross the streams too much.
And that's something where within a lot of my customer environments, when you're talking about millions of files per subdirectory, especially with medical imaging, DIFACs, things like that, I mean, that's when they really want to start distributing out the files simply to get better performance.
Right, based on limitations of the number of files per directories that each one of those, let's say, core filers can support, right? I mean, that's their motivation, right, to work around those issues.
Yeah.
But no, so yeah, the way the global namespace works is it drops you off into a branch of a file system or the root of a file system on the back end, and you're now within that file system.
You talked about you chose to maintain integrity.
Yeah.
What did you mean by that? Is there a
So
technical
one of the
reason?
products that I mentioned there, like the F5 ARX, for example, it would basically stripe. So you would mount as a client, write files out, and would stripe them. One file here on this on this export from this filer, and then this one over here. So if you were to pull the F5 ARX out of the picture, you'd then have to figure out which file was where on which filer. I mean, the directory structures were all uniform, but you have to actually figure out which one was where after the fact. Right, and our desire was, we didn't want to necessarily have to deal with that hurdle, explaining to our customers that that's what happens when you pull a Avere out of the picture.
Okay. And there are a handful of customers from that space that have found themselves in difficulty because they want to age out of that architecture. Mm-hmm. Unfortunately, it's a fairly proprietary way of addressing it.
I'd like to ask what's probably another basic question. I haven't seen a lot from Avere, so I'm kind of coming into it now. So you do both read and write caching, first of all, but how do you decide on the back end where something's going to go? You have
the client actually
the
client decides that. They mount our V server and they traverse it.
We don't distribute it.
There's a one-to-one mapping between a volume or whatever you call it on the Avere side to something on the back end.
Well, so the client will mount the V server on our product. So from its perspective, it's mounting like an NFS export.
Right.
That is, in turn, is mapped by our system to some source core
So you're
file.
not trying to decide based on performance.
No.
You're just dropping something wherever the administrators configured it to go.
That's correct.
It's not like
and that's what and the flash move feature that we have, for example, that actually enables an administrator to be like, well, maybe it wasn't a good idea to dump all these files on this one filer. I can now move them to another filer without having to reconfigure my client
That'd be after the
paths or
fact.
anything like that. And that would be after the fact, yeah.
Thank you.
Will it do
no
anything to protect against an outage of one of the underlying NAS devices? Like if I have an outage of my NetApp or something like that, would I still be able to do writes?
I mean, you will to a certain extent, but I mean, there's only so much that we can
for a
handle
limited
before
period
we.
of time.
Yeah, I mean, and
It's in cache, right?
yeah, it's in
You could
cache.
read if it was
Right.
in cache. Yeah.
But essentially, we encourage our customers to have a highly available NAS infrastructure for business continuity purposes, right? So if they're like, oh, we're not putting HA on this filer, and that thing goes down, they can write some data to us and read some of it cache back. But if they hit a file that's not in cache or something that needs to get pushed out of cache, they're kind of now stuck waiting for that thing to come back.
Yeah.